Hi students. Now today we discuss the topic summation of series using the definite integral as the limit of a sum. So in mains exam this is very simple topic. So you will get one question in mains examination. So then out of 3 to 4 exams they will give at least two times for this type of question. So which is very simple topic, just a matter of only 1 hour class, okay na, which is simple topic. Summation of the series using definite integral as the limit of a sum. So for this algorithm, that means what? We are having 3 steps exactly. Express the given series. Express the given series in the form of limit of n tends to infinity 1 by n into sigma f of r by n. Any series is given, you have to express. Now replace, after reducing this one, replace sigma. In place of sigma you write integral. In place of r by n you write x. In place of 1 by n write dx. Now this becomes, see here, just like a definite integral. Now how to find the limits? Obtain lower and upper limits by computing limit of n tends to infinity r by n for the least and the greatest values of r respectively. That means what? Sigma, if I write r is equal to, suppose the expansion r equal to 0 to n. 0 to n. What is r0? So in r by 0 by n, that is 0 is the lower limit. Suppose if it is n, you write in place of r, you write n by n, the value is 1. So that becomes integral 0 to 1 some function. Okay na? Express the given series, first point, in the form of limit of n tends to infinity 1 by n into sigma f of r by n. In place of sigma, you write integral. In place of r by n, write x. In place of 1 by n, write dx. And how to find the limits? By finding limit of n tends to infinity r by n for the least, that means lower limit and upper limit. Okay na? Just write down. Now, the first problem. Limit of n tends to infinity n by n square plus 1 square plus n by n square plus 2 square plus n by n square plus 3 square plus and so on, n by 2n square n by 2n square. So the given series is limit of n tends to infinity n square, n square, n square, 1 square, 2 square, 3 square. This you write n square plus n square, that is 2n square. Now notation sigma, this is the limit of n tends to infinity sigma. So this is varies r equal to 1 to n. 1 to n. So this is n by n square plus r square. If write r equal to 1, r equal to 2, r equal to 3, r equal to n, so you get this above series. That is limit of n tends to infinity. Now I am multiplying dividing by n. Sigma r equal to 1 to n. So this is dividing by n, multiplying by n by n square plus r square. That is limit of n tends to infinity 1 by n into sigma r equal to 1 to n square. There n square is taking common. 1 plus r by n whole square. Okay, na? Now these gets cancelled. Okay, na? Now the sigma becomes integral. R by n becomes x. 1 by n becomes dx. And the limits, lower limit. How to find lower limit? Limit of n tends to infinity r by n. Where r is what? If write r equal to 1, you get lower limit. That is limit of n tends to infinity 1 by n. That is 0. Next to upper limit. That equal to limit of n tends to infinity r by n. Where r is equal to n. So this is limit of n tends to infinity. So this is n by n, which is equal to 1. Okay. Therefore the given series. Okay. Na? Therefore the given or expression or given series equal to. Now this becomes 1 by n becomes what? Dx. So sigma becomes integral. R by n becomes x. Therefore limits. Therefore it is 0 to 1. 0 to 1. So this is 1 by 1 plus x square dx. So this is sigma becomes integral. R by n is x. 1 by n is dx, which is equal to tan inverse of x. Limits for 0 to 1. So tan inverse of 1 minus 0. That is pi by 4 is the answer. Okay. Write down. Next one, limit of n tends to infinity 1 by n plus 1 by n plus 1 plus 1 by n plus 2 plus and so on 1 by 3n is equal to first reduce limit of n tends to infinity sigma, you write r equal to, so this is n plus 0, n plus 1, n plus 2, n plus 2n. This you write n plus 2n. n plus 2n. Okay. r equal to 0 to 2n. 1 by n plus r. 1 by n plus r. That is the limit of n tends to infinity sigma r equal to 0 to 2n. 1 by n is taking common 1 plus r by n. 1 plus r by n. 1 by n becomes dx. R by n is x. Sigma is integral. Now we have to find the limits. Lower limit. Limit of n tends to infinity r by n is equal to limit of n tends to infinity where r is 0, 0 by n, that is 0. Upper limit, limit of n tends to infinity, so this is r by 2 r by n, that equal to limit of n tends to infinity, where r is here 2n, so this is 2n by n, that equal to 2. Okay, now therefore the given expression or the given series is equal to this is integral 0 to 2 1 by 1 plus x dx. So this is integral of 1 by x, which is log x. So this is log of 1 plus x, limits for 0 to 2, that is log 3 minus log 1. Log 1 is 0. So log 3 is the answer. Next problem. Limit of n tends to infinity 1 by n into sigma r is equal to 1 to 2n. This is r by root of n square plus r square. So it is given directly. It is given directly. So this is the limit of n tends to infinity. So this is 1 by n into sigma r equal to 1 to 2n r by, take n square is taken common, that becomes n, root of 1 plus r by n whole square. Okay, na? So this is the limit of n tends to infinity, so this is 1 by n into sigma r equal to 1 to 2n, so this is r by n by root of 1 plus r by n whole square. So what is lower limit is equal to limit of n tends to infinity r by n, where r is 1 by n, that equal to 0. Upper limit is limit of n tends to infinity r by n, where r is 2n by n, that equal to 2. Okay, therefore the given limit or given expression integral 0 to 2, so this is x by root of 1 plus x square dx. Okay, now this becomes integral, and this is x and this is dx. Now we know this formula, f dash x by root f of x is 2 root f of x. So multiply and dividing by 2, 1 by 2 integral 2x by root of 1 plus x square dx, limits for 0 to 2. So f dash x by root f of x, that is equal to 2 root f of x, limits for 0 to 2 gets cancelled. Now applying the limit, upper limit is, so this is root 5 minus 1, so root 5 minus 1 is the answer. Next one, limit of n tends to infinity, sigma r is equal to 1 to n, 1 by root of 4n square minus r square. This is also given directly. So this right, limit of n tends to infinity, sigma r equal to 1 to n, 1 by n square common, that is n, 4 minus r by n whole square. Now given limit is equal to, or given expression. So this is what? This is sigma, means integral. So this is 0 to 1, 1 by root of 4 minus x square dx. I think you know the limits. What is the lower limit? Limit of n tends to infinity, r by n, where r is 1, 1 by n, so that is 0. Upper limit n by n, that is 1. So this is 1 by root of a square minus x square form, sin inverse of x by a. This is sin inverse of x by 2, limits 0 to 1. Upper limit is sin inverse of 1 by 2 minus sin inverse of 0. So sin inverse of 1 by 2 is sin 30. So this is pi by 6 is the answer. Next one, limit of n tends to infinity, sigma r is equal to 1 to n, 1 by n into root of n plus r by n minus r is equal to. This is, you write, limit of n tends to infinity, sigma r is equal to 1 to n, 1 by n into root of. See here, n is taken common, there also n is taken common. N common, 1 plus r by n by, this is root, n common, 1 minus r by n. So this gets cancelled. Okay, na? Therefore that is equal to, this becomes integral 0 to 1. So this is x, this is dx, this is integral. So this is root of 1 plus x by 1 minus x dx. So I think you know how to integrate this. So this is what? Integral 0 to 1, multiplying dividing by 1 plus x into 1 plus x by 1 minus x square dx. Multiply and dividing by 1 plus x. That is equal to integral 0 to 1, 1 plus x by root of 1 minus x square dx. So this is split into two parts. Integral 0 to 1, 1 by root of 1 minus x square dx plus integral x by root of 1 minus x square dx. Limits 0 to 1. 0 to 1. Now the first one is direct one. First one is what? This is nothing but sin inverse of x. First one is, that is equal to sin inverse x. Limits for 0 to 1, Next, derivative of 1 minus x square is minus 2x. So multiplying and dividing by minus 2. Minus 1 by 2 integral minus 2x by root of 1 minus x square dx. This is f dash x by again root f of x form. For this applying the limit, upper limit is sin inverse of 1 is pi by 2 minus 1 by 2 into, so this is 2 root f of x, 2 root 1 minus x square, limits for 0 to 1. There gets cancelled. So this is pi by 2 minus of, if you are applying the upper limit 1 minus 1 is 0, minus lower limit is 1. Therefore, that is equal to pi by 2 plus 1 is the answer. Next one, limit of n tends to infinity, n plus 1 by n square plus 1 square plus n plus 1 by n square plus 2 square plus and so on. This is 1 by n is equal to, so the series is n plus 1, n plus 1, n plus 1 and so on. This is n plus 1. So this is, okay na? What about last one is what? N plus 1, so this is not n plus 1, that is n plus 2. N plus 1, this is n plus 2. N plus 2, next one is n plus 3 by n square plus 3 square and so on. That is equal to limit of n tends to infinity, n plus 1 by n square plus 1 square, n plus 2 by n square plus 2 square. Plus and so on. Last one, n plus n by n square plus n square, which is 2n by 2n square, that is 1 by n. Now express in terms of sigma notation. Limit of n tends to infinity, you write sigma, okay na, n plus 1, n. So this is n plus r by n square plus r square, where r equal to 1 to n. If write 1, this term, n is 2, this term, n is n, r is n, you get this term. Okay. This integral, limit of n tends to infinity, sigma r equal to 1 to n, there n common, 1 plus r by n, by n square common, n square, 1 plus, so this is 1 plus r square by n square, okay na? So this n, 1 n cancel, limits as usual 0 to 1, therefore this is integral 0 to 1. So this 1 by n, that becomes dx. So this is 1 plus x by 1 plus x. by, so this is 1 plus x square dx. Okay, now this is also, this is integral 0 to 1 by 1 plus x square dx plus integral 0 to 1 x by 1 plus x square dx. Now the first one is direct tan inverse of x. What about second one? That is of the form f dash x by f of x form. This is tan inverse of x plus these are multiplying dividing by 2. 1 by 2 integral 0 to 1 2x by 1 plus x square dx. Here the limits 0 to 1. Upper limit is tan inverse of 1 pi by 2. Lower limit is 0 plus 1 by 2 into this is derivative of 1 plus x square is 2x. F dash x by f of x, that is log of 1 plus x square, limits 0 to 1. So if you are applying the limits, that is equal to pi by 4 plus upper limit is in place of x write 1 by 2 into log 2 minus log 1 is 0, lower limit is 0. So answer is pi by 4 plus 1 by 2 log 2. Next one, limit of n tends to infinity 1 cube by n power 4 plus 1 power 4, 2 cube by n power 4 plus 2 power 4 plus and so on 1 by 2n is equal to this is limit of n tends to infinity, so this is 1 cube by n power 4 plus 1 power 4, 2 cube n power 4 plus 2 power 4 plus and so on n cube by n power 4 plus n power 4. This is what n cube by 2n power 4, which is 1 by 2n. So this is the last term. Now express sigma notation. Limit of n tends to infinity, sigma, you write r equal to, so this is what 1, 2 and so on, 1, 2 and so on. So this is what r cube by, so this is n power 4 plus r power 4, r equal to 1 to n. Okay, na? R equal to 1 to n. If you write r equal to 1, r equal to 2, r equal to n, this one. This is equal to limit of n tends to infinity, r cube by n power 4 common. So this is 1 plus r by n whole power 4. That is equal to limit of n tends to infinity. So this is 1 by n into, so this is r by n whole cube by 1 plus r by n whole power 4. Now r by n is x, 1 by n is dx. That is equal to, same as the limits are 0 to 1. So this is x cube by 1 plus x power 4 dx. Okay na? So this is again f dash x by now the derivative of this is what? 4x cube. So we are multiplying and dividing by 4x cube by 1 plus x power 4 dx. That is equal to 1 by 4 into f dash x by f of x, log mod f of x. Log of, this is 1 plus x power 4. Limits for 0 to 1. If you are applying the upper limit, this is 1 by 4 log 2 minus, well, log 1 is 0. So answer is 1 by 4 log 2 is the answer. Next one, limit of n tends to infinity. So this is n power 1 by 2 by n power 3 by 2 plus n power 1 by 2 by n plus 3 whole power 3 by 2 plus n power 1 by 2 by n plus 6 whole power 3 by 2 plus and so on. This is n power 1 by 2 by n plus 3 into n minus 1 power 3 by 2 is equal to this reduces into sigma notation. Limit of n tends to infinity, you write sigma. So this is fixed, n power 1 by 2 by, so this is n plus multiples of 3. So this is also write 3 into r, just like 3r whole power 3 by 2, where r equal to 0 to n minus 1. If write r equal to 0, r equal to 1, r equal to 2, r equal to n minus 1. In place of r, you write n minus 1, so you get the last term. Okay, na? That is equal to, it is sigma r equal to 0 to n power 1 by 2 by, you can take n is taken common, that becomes n power 3 by 2 into 1 plus 3 r by n whole power 3 by 2. So that is equal to limit of sigma, this is limit n tends to infinity is there, limit of n tends to infinity, limit n tends to infinity sigma r equal to 0 to n minus 1. So this is n power 1 by 2, n power 1 by 2 gets cancelled, that is 1 by n. So this is 1 by 1 plus 3r by n whole power 3 by 2. Okay. Now, what about upper limit and lower limits? Lower limit is limit of n tends to infinity r is 0 by n, that is equal to, so this is 0. Upper limit is what? Limit of n tends to infinity, so this is n minus 1 by n, where r by n, r is n minus 1. So if take n is taken common, 1 minus 1 by n, okay, na? Which is 1. Therefore, this is equal to integral 0 to 1. 1 by n becomes dx. This is integral. So, integral 1 by 1 plus 3x whole power 3 by 2 dx. Okay, na? I think you know how to integral this. You write integral 0 to 1, 1 plus 3x whole power minus 3 by 2 dx. Okay, na? This is x to the power of n form. So this is equal to its integral is 1 plus 3x whole power minus 3 by 2 plus 1 by minus 3 by 2 plus 1. Limits for 0 to 1. 0 to 1. So this is what? Minus 3 by 2 plus 2. That is minus, this is minus 2 of, this is 1 plus 3x whole power minus 1 by 2. Limits 0 to 1. Okay, na? If you are applying the limits, minus 2, upper limit is what? You write 1. Upper limit is 1. So this is 4. 4 power minus 1 by 2. Minus lower limit is 0. Lower limit 0. Lower at 0 means what? In place of x, write 0. So this is minus 1. Okay, na? So this is equal to minus 2 into, so this is 1 by 2 minus 1. 1 by 2 minus 1. So again, just small mistake is there. By 3, x power n plus 1 by n plus 1 into derivative of 1 plus 3x is what? 3. So this is becomes 3. So this is 2 by 2 by 3. That is equal to minus 2 by 3 into minus 1 by 2, which is 1 by 3. 2 gets cancelled. So 1 by 3 is the answer. Next one, limit of n tends to infinity 1 by n into sin square pi by 2n plus sin square 2 pi by 2n plus and so on. Sin square n pi by 2n is equal to so this is limit of n tends to infinity 1 by n into we write sigma, so 1 pi 2 pi and so on, so n pi, so sigma r is equal to 1 to n. This is sin square r pi by 2n, so 2n fixed, 2n where r equal to 1 to n. So this is directly integral 0 to 1, so this is a sin square, so r by n is x, so this is pi x by 2 dx, sin square pi x by 2 dx. You know that what is the cos 2x formula? Cos 2x is 1 minus 2 sin square x. Therefore, this is 2 sin square x is equal to 1 minus cos 2x. So, sin square x is equal to 1 minus cos 2x by 2. Okay, na? So, this is integral 0 to 1, 1 minus cos 2x, 1 minus cos of 2x is what? 2 into pi x by 2, that is pi x by 2 dx. So this is 1 by 2 into integral 0 to 1 minus cos pi x dx. So this again, this is a general integration. 1 by 2 into integral of 1 is x, limits for 0 to 1. Integral of cos x is sin x. So this is minus, so this is sin pi x by pi, limits for 0 to 1. Limits 0 to 1. So you know sin pi value 0. So this applying the limits. Here this is 1 by 2 into 1. Lower limit is 0. Next minus. So sin pi is 0. Sin 0 is also 0. So this is 0 totally. So that is what answer is 1 by 2 is the answer. Okay. Write down. So just you try same model problems. Limit of n tends to infinity root 1 plus root 2 plus root 3 and so on root n by n root n. Next one, limit of n tends to infinity. This is the root of n plus 1 plus root of n plus 2 plus and so on root of 2n by n root n. Third one, limit of n tends to infinity. So this is 1 by root of n square plus 1 square plus 1 by root of n square plus 2 square plus and so on 1 by root of 2n square, root of 2n square. So these are all same model. So this is limit of n tends to infinity 1 power 9, 2 power 9 plus 3 power 9 plus and so on n power 9 by n power 10 is equal to. So, okay. So these are all same model problems, just to try yourself. Okay, ma? Thank you.